So this is the third in a series of videos about solving, I want it to be in black here. Let me erase that. Solving systems of equations. And this time we are going to use what's called the addition method. Or sometimes it's referred to as the elimination method. So addition method, sometimes it's called the elimination method. Okay, so the way that this works, so it's to solve systems of equations like we did before. So for example, let's say that we were given the equation 3. Oh, that's a terrible looking 3. Let's make it a little nicer. So 3x plus 8y equals 23, and minus 3x minus 10y equals, negative 27. So in this case, like before, I could pick to solve for one of the variables. But if I pick, say, the first equation, and I try to solve this for x, I'm going to have to end up dividing everything by 3. And 8 divided by 3 is not a nice number. Neither is 23 divided by 3. If I solve for y, I'd have to divide everything by 8. And again, 23 divided by 8 is not a nice number, and 3 divided by 8 is not a nice number. So no matter what, you would end up with these terrible-looking fractions. And nobody really likes fractions. So we're going to look at another method. So one of the neat things to notice here is if you look at, I happen to have a positive 3x and a negative 3x when I look at the two different equations. And so if I added these two equations together, this positive 3x here and the negative 3x here, they would actually cancel each other out. And then if I add 8 and negative 10, that would give me negative 2y. And then here, the 23 minus 27, that would give me a negative 4y. Oops, negative 4, not just y, negative 4. That would give me a negative 4. And now I could easily solve both equations by dividing by 2. And so y actually ends up to be this nice number 2. And then just like we did before, we can take the value here, the 2, and we can plug it back into either one of these original equations to get my next value. So if I plug it into the top equation, I would have 3x plus 8y equals 23. So 3x plus 8 times 2 would be 23. So 3x plus 16 is going to be equal to 23. I could subtract 16 from both sides. So 23 minus 16 would be 7. And now I could divide both sides by 3. And so x turns out to be 7/3. And then just like before, right, I have to write x equals 7/3, y equals 2. Or I could write the ordered pair 7/3, comma 2. So let's look at another example of this addition method. So in this example, so I'll just write these as solve, and then this way I can write a couple examples. 7x minus 4y equals 3, and negative 8x plus 3y equals 6. And so if I look here, right, again, if I try to divide to solve for one of these x's or y's, I get really ugly fractions. The problem, though, is unlike the last example, right? In the last example, the x's, I could just add it up together and they cross out. Here, they don't match, right? I have one being positive and one being negative, and that's good because I need one to be positive and one to be negative. But the numbers in front of them don't match. And so there's an easy trick to actually make them match. And so all you have to do is, I'm going to rewrite these equations so that I still have the original equation, but now you can see what I'm doing here. Okay, I want them to match. So what I'm going to do is I'm going to notice that there is a 7 here. And so I'm going to take this bottom equation and I'm going to multiply it all by 7. And there is an 8 here. So I'm going to take this top equation and I'm going to multiply it by 8. And now I'm going to get a new set of equations. So if I do that, so 8 times 7 is 56. So I have 56x minus 32y equals 24. Remember, this 8, it's got to go to all the pieces, right? And then the second equation is going to be negative 56x plus 21y equals 6 times 7 is 42. And so now, if I add these up here, right, I'm going to have this negative 31 plus this 21, right? Because remember, we're adding them, so the negative 56x and the 56x go away. The negative 32 and the plus 21 would give me negative 11. So negative 11y is equal to 66. And if I divide both sides by negative 11, I end up with y being equal to negative 6. And now, if I take that and I plug it back into one of the original equations, it doesn't matter which one. So we'll take the first one here, 7x minus 4y equals 3. And if I plug that in, I'm going to have 7x minus 4 times negative 6 equals 3. So 7x plus 24 equals 3. If I subtract 24 from both sides, I'm going to have 7x equals negative 21. And now if I divide both sides by 7, I end up with x is equal to negative 3. And so my answers here are x equals negative 3, y equals negative 6, or again, you could write it as that ordered pair, negative 3 comma negative 6. Okay, so I have one more of these to kind of show us. So this example, we have, example B, we have 2x minus 9y equals positive 20, and 3x minus 4y equals negative 8. So on this example, again, it's not real nice to solve for any of the variables. I don't have stuff that I can just add right away and things cross out. So I have to change it up a little bit. And the way that I'm going to change it up, so again, I'm going to rewrite it like I did the last time, so then I can change it. 3x minus 4y equals negative 8. And so if I start with the x, so the first thing to notice here in the x is both of these things are positive. So if they're both positive on the x, or like on the y where they're both negative, what I want to do is when I multiply, I'm going to multiply the first equation by a negative number. That way I end up getting a positive coefficient and a negative coefficient, and things will cancel each other out. And the negative number I'm going to multiply by is this number right here. So I'm going to multiply everything by negative 3. And then the bottom equation, I'm going to look here, and oh, it's a 2, so I'm going to multiply by the 2. And so now this is going to become negative 6x plus 27y equals negative 60, and 6x minus 8y equals negative 16. And now I can add these together, and when I add these together, notice I have a minus 6x and a plus 6x, so those go away. And then 27y minus 8y, that ends up being 19y, and this is negative 76. And then if I divide both sides by 19, y ends up being negative 76 over 19. Now, that is not a really nice number to plug back in, right? If I go to plug that back into one of these equations, it's super ugly. I'm going to have to deal with these like terrible looking fractions. And people in general don't like doing fractions. So what I can do instead, and this even allows me to practice elimination a little bit more, is I can go through this process, but this time instead of trying to get rid of x's like I did here, I got rid of the x's, let's get rid of the y's. So I'm going to rewrite my equation again. So 2x minus 9y equals 20. And 3x minus 4y equals negative 8. And this time, I'm going to get rid of the y's. So what I'm going to do is I am going to take this number here. And so if I notice, again, like I said, the stuff in front of the y's is, they're both negative. So I want one of them to turn positive. So I'm going to multiply it by negative. And then I'm going to multiply it by that number 4. The other one, I'm just going to take the 9, multiply by 9. So we end up getting negative 8x plus 36y equals negative 80. And 9 times 3 is 27x minus 36y. And 8 times 9 is 72, so minus 72. And if we add these together, so negative 8x plus 27x, that would also give me 19x. These, the 36y and the minus 36y, go away. Equals, and if I add these two together, I get negative 152. So I've got 19x equals negative 152, and I divide both sides by 19, and x turns out to be negative 152 over 19. So my solution here is x equals negative 152 over 19, y equals negative 76 over 19, or, oh, why did that happen? Or the point minus 152 over 19, comma, negative 76 over 19. And it doesn't matter which method you use. So on Alex, it's going to try to tell you use substitution or use elimination. It doesn't matter. If you like substitution, even with all the crazy fractions, go for it. If you like elimination all the time, you can use elimination all the time. It doesn't actually matter. All that matters is that you can find the 2 points.